Okay, so this question talks about the principle of redundancy. So here's a quick definition from Wikipedia. In engineering, redundancy is the duplication of critical components or functions of a system with the intention of increasing the reliability. So basically, if your alarm clock doesn't work, or if you're afraid it might not work, why not buy two? So this happens a lot where they will double up fail-safes and things of that nature in sorts of productions. But the problem we're going to work with today is dealing with an alarm clock. So if it says your alarm clock has a 0.83 probability of working, so we're going to find event A as your alarm clock working, and the probability of that is 0.83. Notice this is a decimal formation. We could write this as a fraction or percent, but for the purpose of this problem, we're going to work with this as a decimal. So it says, what is the probability that your alarm clock does not work? This is the complement. So we are finding the probability that A does not work. You might also see it written, the complement written like this, depending on what research you're looking at. But we do that by doing 1 minus 0.83. So 1 minus 0.83 gives us 0.17. So the probability that your alarm clock does not work is 0.17. Again, you might consider getting a new alarm clock if this one is not very reliable. But for the purpose of this problem, you don't get a new alarm clock, you buy a second alarm clock. So the probability that it does not work is 1.87. It says if you use two alarm clocks, what is the probability that they both do not work? So let's figure out the probability that they both fail. Well, we know that we have a 0.17% chance of the first one failing. We're going to assume that the second alarm clock is just as reliable or unreliable. So we want to find the probability that the first one breaks and the second one breaks. So it's going to be 0.17 is the probability that the first one does not work times 0.17 is the probability that the second one doesn't work. Please know that this is the same thing as 0.17 squared. So I'm going to do 0.17 squared, which gives me 0.0289. We know as a percent that this is basically 2.89% chance that they both fail. Okay, so what's the probability that you will be woken up if you use two alarm clocks? This is where it starts to get a little tricky because it doesn't specifically say what probability we're asked to find. The probability that you will be woken up, what does that mean? That is the probability that at least one alarm clock works. Because either they're both going to work, one or the other will work, or they both fail, right? So rather than doing either they both work, first one fails, second one fails, and add those probabilities together, when we find the probability of at least one, the way we approach this is we say, let's find the probability that none work and just do 1 minus that, right? Because you think about it, here are the situations. Either they both work, the first one fails, the first one fails, but the second one's good. The first one's good, but the second one fails. Or they both fail, right? This is the probability that none of them work. These are all part of the probability that at least one work and you'll wake up for your alarm. So rather than doing all three of these probabilities separately and adding them together, we're going to take a look at 1 minus the probability that none of them work. So what is the probability that none of them work? You actually did that right here. You did the probability that both alarm clocks do not work. So to find the probability that at least one works, it's 1 minus 0.0289. So we're going to do 1 minus, here's a nice little trick in the graphing calculator. You actually have this on any type of calculator you're using. But if you find that little button that says answer, it's right above the negative on my 83. If I do 1 minus the answer, that will give me, so it's 1 minus what I had right above. So 1 minus 0.0289 is 0.9711. So the probability that you have at least one working alarm clock is 0.9711, or 97.11%. Depending on how the online homework, once you enter, you're going to put in one of these two. So it says, does the second alarm clock really improve your chances? Well, if we have one alarm clock, it was 83% chance, right? If we buy a second, we have a 97.11% chance. I would say that that is significantly better, right? 83 versus 97.11. So the answer to that question would be yes, it does improve our chances. So again, I think the tricky part here is taking a look at the probability of at least one. So kind of breaking that down.